Welcome back, Chemistry 30. This is the EQ2 solution equilibria review for the upcoming exam. So we'll look at what the unit consists of here. EQ 2.1, saturated solutions and solubility. EQ 2.2, factors affecting solubility. We combine those two together initially to look at kind of an introduction into solution equilibria, looking at saturated, unsaturated, supersaturated solutions, solubility, etc. Then we went to EQ 2.3, introducing KSP, the solubility product, in which we compare the ion concentrations of the compound being dissolved to see what it is like in terms of dissolving. And then EQ 2.4, and we did some calculations there involving if you're given the molar solubility, what's the KSP, or if you're given the KSP, what's the molar solubility. Then 2.4, we looked at kind of the same thing, except this time if you had some of the ions present initially. So if you're dissolving a compound in a solution that contains a common ion. And then 2.5, precipitation of ions. If we have two substances, two compounds, mix them together, an anion and cation may come together and make a precipitate. And we looked at calculating, is it a possibility or not, by comparing the experimental KSP value, which we called Q, and comparing it to KSP. So if we take a look here, a lot of the marks are in the three questions that I give you, with there only being three multiple choice questions. So three multiple choice questions, I can give you a hint that one of those questions will be interpreting a solubility graph, like we had in EQ 2.1 and 2.2, giving you some information about dissolving something in water and determining by looking at the solubility curve whether it's supersaturated, saturated, or unsaturated. And then moving on to the problems, I basically have one question from each of the sections from 2.3 to 2.5. So 2.3, we did two types of questions there. You could be given the molar solubility and you're asked to figure out KSP through the use of an ice chart. Or using that ice chart, I could give you the KSP and you have to figure out the molar solubility, so you have to use the variable x to figure that out. So that's worth 6 marks. Number 2 is very similar to the molar solubility calculation, except you are given an initial ion in a solution. So it's like you're dissolving a compound in water that already has some dissolved ions. And one of those dissolved ions will be conflicting with what you are dissolving because there's a common ion present. So if you look back in EQ 2.4, you'll see examples of that. That's worth 8 marks. And then number 3 was a bigger question, precipitation of ions. So determine if a precipitate forms by comparing the Q value to the KSP when dissolving two compounds together to make a solution. So you dissolve them. I'll be giving you the KSP value of the compound that we're looking at. So you have to find the concentration of each of those ions that make up that compound, figure out the experimental KSP, and then go from there, comparing it to the KSP to see what happens. That's worth 50 marks, so that's almost half the test there. You are allowed to use this review paper because I kind of outlined the steps in which we did this. Or if you want, you can write these steps out so you have them, and it kind of gives you a hint in terms of what we're doing at each step. So we can go back and, of course, use the notes, but the steps kind of outline what's going on in each step. So calculating the moles of each compound by rearranging C equals N over V to solve for N. Then, of course, we want to know the moles of the ions in question being analyzed, so we write dissociation equations and see what the ratio is, figure out the number of moles. Then number 3, figure out the total volume of the resulting solution. So that's kind of the first half in which we did for that question. And then now that we know the moles of ion that we're analyzing and the volume of ions that we're analyzing, we can then figure out the molar concentration of each of those ions. And then once we know that, we can write down the dissociation equation and calculate the KSP value, really, but we call it Q because we're comparing it to the actual given KSP value. So then we see if Q is bigger than KSP, then it's going to be a precipitate because we have more ions than we should to make a saturated solution, so the extra will fall to the bottom as a precipitate. Or if Q is less than KSP, we have an unsaturated solution, so we could actually have more ions present. Okay? And again, yes, this is an open exam, so there'll be no rewrite. You are allowed to use your notes. You are allowed to use these steps. So make sure you go through that. And again, there's kind of an emphasis on those three calculations for those three questions at the end. All right, we'll see you again.